Thank you very much, Dave. One of my favorite companies that I'm sure many of you heard about is Control Data Corporation. I mean, it's back in the 60s and 70s, they were making some of the fastest computers. They made a lot of contribution for scientific research. And partially I love it because my dad used to work there, but you know, the Robert Price, president of Control Data, published a book about 3 years ago that showed truly that how he utilized innovation and he built a computer giant that, you know, contributed to space exploration and, you know, some of the best advancements in computer science. There are lots of interesting things in that book, which is called I for Innovation, but there is one quote there that I think all of us will agree upon, and he's saying that innovators are made, not born. And I think many of us in this room have tried to make that happen, either in our companies or in our universities. And we have taken different approaches. And, you know, same thing, a similar timeline with Control Data. Because of the forces of industrialization and the post-war economy, there also has been a lot of advancement in our educational systems. You know, the blackboard, you know, people get around the blackboard and learn and, you know, interact and collaborate with their professors. But if you want to kind of look at the timeline that, you know, where we were in 1970s, and this is a Control Data cyber machine in 1972, and where we are now, where we have, that's a Nexus S, the Android Nexus S from Google, it's 1,000 times faster and more powerful than that machine. It has NFC, it has a different form factor, it can do many things, it has a new infrastructure to support it. And you want to compare it with our educational system, and that's today in many of our classrooms. You see that, you know, there are lots of similarities between what we used to have in the 60s and 70s and what we have now. So I think one thing, and all of us are approaching innovation from different ways, but, you know, at least from the university standpoint, what we have been trying to do to see how we can approach it differently in a university setting. I'll give you another example. This is the picture of our engineering center at Ryerson. And on the second floor, we have the Department of Computer Science. And probably within the proximity of a few meters, we have lots of labs. We have the teleoperated autonomous systems lab. We have the network-centric applied research lab, and they are very close to each other. We have the ubiquitous and pervasive computing lab. We have the computer science lab, and then we have the computational intelligence initiative lab. There are lots of interesting things happening in these labs, but they share something very much in common. They are all behind closed doors. You need to have at least 2 levels of security to get to these labs. And the interesting thing from the social point of view is that we have about 50 graduate students and postdocs working in these labs that they don't know even each other's names. So what you can think of is that that's a challenge. If this is happening in a partial part of a department, and that's not Ryerson, that's everywhere, in many universities across the world, you can see that we are doing something wrong. We need to collaborate more, we need to collaborate differently. So what we decided to do first, we said, well, let's break the walls. Let's bring and support multidisciplinary research, bring people together from different disciplines, mechanical engineering, fashion, computer science, and, you know, like many other approaches, let's find an area at the university that nobody's using, either a basement or an abandoned lab, and call it a multidisciplinary research setting. We did that, and this is what happened. You know, very few people attended, and they were not motivated to come to that lab. So we took a big risk, and I think probably being a risk taker, as Kunal mentioned, is probably one of the most important things to being an entrepreneur. So we worked with our president. We said we are going to get one of the most exclusive real estates in Toronto, where actually Google's headquarters is in Canada, and then we are going to make it an incubation space. We are going to make it a lab space and an incubation space, and then we are going to see what's going to happen, and we took a big risk. Another approach that we took, which is probably one of the biggest challenges of the universities, we said that, well, what are we going to do with the intellectual property? We said we don't want a piece of the IP that is going to come to that zone. You can bring your idea here, you can collaborate, and whatever you build belongs to you, the inventor. The university doesn't want anything out of that. And then we, of course, had a plan. And our plan was, well, We don't know what's going to happen, but we are going to take a risk. There were lots of issues that we overlooked when we did that because of all the possible things that could go wrong. So what we did, we created this space. We brought students together from different disciplines, and we intentionally made them to sit together. Business students, fashion students, mechanical engineering students. Instead of putting them in separate labs, we brought them together intentionally to see what's going to happen. Another thing that I'm sure you know about the co-op programs in our universities. We sent some of our best students to co-op programs, University of Waterloo, U of T, Ryerson. What we do to them during the second year and third year of their undergrad studies, we send the best of them to cubicles of great companies like IBM and some of the Fortune 500 companies. What they tell them is that, well, this talent should be used to do software testing, to fix that computer, or not very innovative stuff. So what we tried to do, we said, well, we are going to get the co-op funding. We are going to bring a student to this innovation space. We ask the company to support him or her, and then you can go crazy as much as you can to innovate as much as you can during the most innovative year of your life. And that was a better approach. We had the partnership with the companies. The companies actually funded the co-op students, but we took another approach than before, kind of the cubicle approach with our co-op students. We also brought students from very different disciplines. We brought students from mechatronics and mechanical engineering and intentionally made them to sit with students from radio, television, arts to see what's going to happen. These are two undergraduate students, and normally in our schools we don't allow undergraduate students to get involved in research. And these are two undergraduate students in their second year and third year, and they recently built a prosthetic arm that can be controlled with brain signals, and they're planning to sell it on the internet. And it's amazing. I mean, this is type of a research that is happening in probably some of the most advanced labs in the world. And we have now two undergraduate students that by having access to this infrastructure is coming with lots of ideas. And the university, the infrastructure is supporting them to make that. This is another of my colleagues, Jonathan, who's a graduate of radio, television, arts. He's doing a lot of work with gesture technologies, as you have seen it. You can use different set of gestures to activate different media triggers on a surface. So what we did, we brought him and we made him sat with some of the people who were doing wireless research. So what we came up with, we said, well, you can actually use these surfaces as kiosks at train stations, that when you go there, you can purchase your ticket, and your ticket is going to show up as a barcode on your phone, and then you can scan that and you can take the train. This wouldn't have happened if the wireless group were in a room and the media group were sitting in another room. It happened because we brought them together. The statistics that we have seen so far is very optimistic. In a period of a year or so, we have created about 200 jobs. We have supported 126 innovators, and we have 55 active projects in the zone. So you can think about it. In our education system, if you can think about it in a way that 10% of your graduates, when they graduate from school, they are not looking for jobs. They will be creating jobs. We will be changing our economy, and we are supporting the fact that in Ontario, we are moving from the manufacturing economy to the knowledge and innovation economy. The other aspect that we are working in the zone is, of course, around mobile, as Dave mentioned. I mean, again, if you think about the ergonomics of mobile, people search for stuff. They are searching for content. Whereas what we are trying to do, which we have an IP for, and we said, well, we are going to bring this IP. We don't care about what happens to it, but let's give it to different set of developers and groups, see what they can do with it. And that's around the concept of context awareness, meaning that how you can process the situational information around the phone and make the information more adaptive, make the device to adapt based on the environmental factors. So a group of students applied it to an airport setting. That, this is probably a familiar story for all of you, a stranded passenger at an airport. But there are lots of information around this passenger in addition to location. Is there a missing flight? If there is a flight delay, is the baggage lost? Are you waiting for someone? How do you get all these information and infer something new? So that was the core engine that we have, which we called it the context processing engine. And I want to show you by opening it up, by following the open source paradigm, how you can contribute to different set of innovations. So this is one of them. That, let's say you're en route to Pearson, you get there, we know your itinerary, you will get different set of services on your handset. When you're in a particular area of the airport, you can change your seat. If you leave, that service will be removed from your handset. If you have a connection flight at Heathrow, when you land there, for example, all the services will change. Now you can purchase train tickets, you can find hotels in the proximity. And again, it's the convergence of a middleware technology, the cloud computing, all coming together using the IP that we built in a research lab. The other example from an airport, during irregular operations, stranded passenger, automatically we will use the business logic because we know that the passenger is a frequent flyer, the flight is canceled. Now she's going to receive a Sheraton coupon on the handset with the taxi service and the direction to the hotel. So all of these are becoming possible because of that small IP that we opened to a bunch of developers in the zone. Another research that we did that, again, contributed the same way was a privacy rule engine. I mean, privacy is probably the biggest challenge in cloud computing and mobile. A group of students did a project using this privacy rule engine that, for example, if I'm working 9 to 5, if the semantics actually say that, if my boss pings my location, he or she will see where exactly I'm sitting in the office. Whereas if it's after 5 o'clock and he or she pings me again, he will only see that I'm out of office, but if my family member pings me, they will get the precise location. So it's contributing to the fact that, you know, the information abstraction and privacy is becoming more supportive for these mobile applications. A group of students applied it to a unified communication solutions that, you know, without downloading anything like Skype or, you know, downloading a particular client, you can actually go on the web, import your friends from Facebook, do all your video chats and audio chats and SMS and interconnection to your phone book. All of that will happen under one umbrella by using that privacy rule engine. So you can cluster a group of people, say, if they call me from this time to this time, my cell phone should not ring, the phone call should be routed to a landline, or all these logics, again, by opening that IP to a group of students. It resulted in international collaboration with us. We deployed a project. It was a fully Canadian developed project, but we had to go to Europe, and that was another challenge for us to prove it. And again, when we did it, we got the interest of some of the Canadian transit entities for its deployment. So basically, the idea was that the Paris Metro passengers could use their phone to navigate their way through in the metro system. Each station is associated with different set of cloud services. You can get location-based services. You can find restaurants and attractions based on the profile, context, and location of the passenger. We built a series of solutions for them to track passengers with disability. So a disabled passenger can share its information with a family member or with the transit authority and then provide messaging solutions. Another area that we focused on was the issue of adaptation. The biggest challenge that you have is that when you take your phone, the environment around your phone is very dynamic. This is an example of an indoor positioning solution you're seeing your location, you can walk in the station, but because it's the tunnel and you're underground, the bandwidth will fluctuate. Now what we will do is that we will adapt the application in a way that you can see the information, but on a textual interface, so you will consume less bandwidth. So you will receive the functionality, but the application is adaptive on the runtime, so you don't have to restart it. So you will see that the usability of the application increases. We built a series of interfaces for blind passengers. So if you give the phone to someone who's blind or low vision, automatically the interface will change in a way that they can talk to the phone or perform gestures on the phone to activate text-to-speech and speech-to-text services. We built some fun apps just to prove what we can do with the technology. We don't have a monetization model for it now, but imagine you're taking the TTC or going from Bloor to college, and it happens a lot that the train is stuck and you're late for your meeting. So what we will do if that happens, we will identify that. We will send an email to everyone who you're going to have meeting with, calculate your distance to the meeting, and send them an email that you're going to be late for this much time. And when you get there, the message is digitally stamped by TTC, so everybody is going to believe you. Or we built some social networking apps that it's basically around the concept of opportunistic social networks, that when you come to an event like this, you don't know many people, but you want to make the most of your networking time, you will look at a graph like the one you see on the middle, and the center node is always you. The people around the center node are the people in the proximity, and the closer the distance, it means that you have more in common with that person based on the profile that you either imported from LinkedIn or Facebook, or you actually pre-filled it before coming to the conference. But if you take the phone, let's say to another smart zone, such as the bar across the street, automatically the semantic will change and the people that you see will change, and you will be able to kind of use that social semantic to communicate with the people. We also did some work around augmented reality, that different augmented reality markers can actually give you different set of information based on your profile. We used it, let's say, for navigation, that you go to one of these train stations, you're lost, you don't want to type on your keyboard. You will point your camera towards a marker, and then we will tell you which direction to go. And if you want to compare it with other solutions such as NFC and RFID, it's much cheaper because it's just a piece of paper and a pattern that the camera can understand. And this is an example of the navigational finding that the marker is giving you different set of information. This is a great example of some of the projects that I showed you, that students from different disciplines are working together, from artificial intelligence, from mobile and graphic communications. And basically, this is a project that we collect context information from your phone, with your permission, of course. But at the end of the day, you don't see anything on your phone. You log into a web page, and you will see the comic strip of your daily life, because we will associate every single context information that we collect. Your location, are you on a car, which one of your friends are in the proximity. Then you will choose your comic template. Oh, I want to create a Tintin comic, or a Dilbert comic, or a Garfield comic. And based on that, at the end of the day, the more you use the system, these comic strips are becoming more relevant and relevant. You can invite your friends to be part of the comic strip. Down the road, if you want to monetize it, you can embed advertisement to it based on the profile of the people. This is probably another last project that I'll talk about. We got a hold of one of these Microsoft Surfaces that, there are tables that can understand barcode. And we tried to apply the same technology, but on a different medium. So imagine you go on a date or you go to a meeting. There is this barcode beneath your wine glass or coffee mug. You put it on the table. We synchronize the profiles together, and then we will create a cheat sheet around the table telling you what topics to avoid talking about and what topics to emphasize without, exposing the privacy. We also worked with a group that was focused on security applications, and we built new ergonomics that people can actually, police force, law enforcement will be able to use these head-mounted displays that when you go to a building, automatically they see the CAD drawings or the camera feeds and all that based on the same technology. So basically, the way I want to wrap up is that all of these technologies became possible because we were not that picky about the IP. We opened it to a group of students, and we kind of waited to see what happens. We had an infrastructure to support them. We emphasized on collaboration, and we motivated the students to give them a space that they really like to come and work. Going back to Kunal's example, that classrooms are boring. How do we provide an experiential learning models that they are actually motivated to come and work there? And we have to understand that the Generation Y, the generation that is in school now, they think, they learn, and they innovate very differently from baby boomers. And if you look at some of our policies that we have in Canada, innovation policies, invention policies, they are all created in the 60s by the baby boomers. So I think it is now to understand that this school, kind of the University 2.0, is becoming possible by understanding the Generation Y. And of course, the biggest thing and most important thing is that the innovation should be fun and social, and it should be in parallel to the current education system that we have. So basically what we can do to make it happen is that for our education system, we should do what Linux did for operating systems, to open it up and let other developers to develop, and what YouTube did for media distribution, that we build the framework, we let the content to come from the users. Okay, thank you.
Thank you.